Lesson 26, Probability Distribution. Example 4. Roulette is a game of chance where the winning result is determined by rolling a marble around the edge of a spinning roulette wheel and observing the specific slot within the wheel where the marble randomly falls. So the roulette wheel is spun in one direction and the marble is spun in the opposite direction. Eventually, the marble loses momentum, falls into the wheel, randomly landing in one of the slots. The resulting slot determines the outcome of the winning bet. There are several bets that can be made in the roulette table. You could bet on the color. It could be red, or green, or black. You also notice that each of the slots are numbered. So you can bet on the individual number, or on groups of numbers. 2 numbers at a time, 3 numbers at a time, 4 numbers at a time, 12 numbers at a time. You could even bet on if the number is going to be odd or even. So in roulette, the roulette wheel is spun and the marble is spun, and it will randomly fall into the wheel, eventually landing on one of the slots, and the resulting outcome could be red 9. So any bet on red, or any bet on 9, or any bet on an odd, or any bet on the first 12 numbers would have won that result. Now, to answer any sort of probability questions involving roulette, we need to completely understand the construction of the roulette wheel. The American roulette wheel has 38 total slots, of which 18 are colored red, 18 are colored black, and 2 are colored green. The red and the black slots are numbered 1 through 36. The green slots are numbered 0 and 00. Construct the probability distribution for betting $1 on black, which pays even money, in the game of roulette, and calculate the corresponding mean and standard deviation. So first we need to construct the probability distribution. To construct a probability distribution, we need to determine all the possible outcomes of this random process, along with the corresponding probabilities of those outcomes. The probability distribution can be displayed in table, graph, or formula form. For this example, we'll construct a probability distribution table. A probability distribution table is a table containing 2 columns. The first column lists the random variable x and all the possible outcomes. The second column lists p of x, the corresponding probabilities of getting those outcomes. So in this case, the random process is betting $1 on black in the game of roulette, of which there's only 2 possible outcomes. You're either going to win that bet or you're going to lose that bet. So the value of the random variable x can take on values depending on whether we win that bet or lose that bet. Here we're betting $1 on black, which pays even money. Even money bets are bets where the amount you risk losing is equal or even to the amount you will risk winning. So in this case, betting $1 on black, we're either going to win $1 or we're going to lose $1. Winning $1 is represented as a +1, and losing $1 can be represented as -1. So +$1 means we've won $1, or minus the $1 means we lost the $1. Now we need to construct the corresponding probability. In order to win this bet on black in the game of roulette, the marble needs to land in one of the black colored slots. So it turns out there's a total of 18 black colored slots out of a total of 38 slots in the American roulette wheel. So there are 18 chances to win out of 38 total on a bet on black. Now the probability of losing that bet is calculated by counting the number of slots that are not colored black. There were 18 red slots and 2 green slots. So if the marble lands in any one of the 18 red slots or any of the 2 green slots, for a total of 18 plus 2 or 20 non-black colored slots out of the total of 38, we would lose that bet. So there's 20 ways of losing out of 38 total on the bet on black and roulette. So here is our corresponding probability distribution. It lists all the possible values of the random variable x, along with the corresponding probabilities for this particular random process. Notice the probabilities all take on values between 0 and 1, And if we were to add up all the probabilities, the 18 plus 20 is 38 out of 38, and 38 divided by 38 is 1 or 100%, accounting for all the things that could possibly happen. Now we need to calculate the mean and the standard deviation. We will use the TI-84 calculator to help us calculate the mean and standard deviation. To calculate the mean and standard deviation based off a probability distribution, we first have to enter the probability distribution into the lists of the calculator. We do this by pressing Stat, Enter, to get to the list editor. Now we have some old data in List 1 and List 2. I'm going to arrow up to the list name, press Clear Enter to clear out old data to make room for new data. In List 1, we'll enter the values of the random variable x, which was a positive 1, enter, and a negative 1. Negative is the button that has the minus sign in parentheses just next to the enter. The subtraction sign that's on the far right represents subtraction, and it's with the operation buttons. So press the negative 1, enter, arrow over to List 2, and in List 2 we'll put the corresponding probabilities. 18 divide by 38, enter, 20 divide by 38, enter. Now with the values of the random variable in List 1 and the corresponding probabilities in List 2, we can calculate the mean and standard deviation by pressing Stat, right arrow to calculate, enter to select the 1var stats command, second 1 for List 1, comma, second 2 for List 2, enter. So we can see the mean, which the calculator represents as x bar, but since we calculated the mean based on the probability distribution, that is, it accounts for the 100% of everything that can happen, or the population, we represent that result with the symbol mu sub x. So mu sub x is approximately a negative 0.053, rounded off. And the standard deviation for this population, or probability distribution, is represented with the symbol sigma sub x. So sigma sub x, it rounds off to 0.999. Thus, we've calculated the mean and the standard deviation for the probability distribution of betting $1 on black in the game of roulette. Now, the units for the mean and the standard deviation are the same as the units for the random variable x. So the random variable x was measuring amounts in dollars. So the mean and standard deviation is measuring amounts in dollars. So the mean, mu sub x, is equal to a negative $0.053, or about minus 5 cents. And the standard deviation, sigma sub x, is approximately $0.999, or rounds off to about $1.